When optimizing the structure or minimizing the energy, IQmol relies on a force field. The force field is basically a set of classical parameters where atoms are treated like masses and bonds are treated as springs. So the force field is just a collection of parameters that define how those are connected to each other. By default, IQmol uses UFF, which is a universal force field. The nice thing about this force field is it applies to every atom on the periodic table. Many force fields are parameterized for certain types of molecules. But we saw in the bond length and angles video, when we minimized the energy with the UFF force field, so when we looked at the angles, that the hydrogen-carbon-hydrogen bond angle was 120 degrees, which is the same as the oxygen-carbon-hydrogen angle. And we know from VSEPR theory that the double bond has 4 electrons in it and therefore repels the hydrogens more strongly. So we know that the hydrogen-carbon-hydrogen angle should actually be somewhat less than 120 degrees, and the oxygen-carbon-hydrogen angle should be somewhat greater than 120 degrees. Again, the reason that they end up being exactly 120 degrees is that we're using a force field that doesn't really account for the fact that carbon can form different types of bonds. So in IQmol, you can actually change the type of force field that you're using. If you go to the Build menu, there's an option to select the force field, and you can see that UFF is currently selected. Of the others, MMFF94 and MMFF94S are very similar, with just some differences in how nitrogen atoms are treated. The MMFF and the GAF force field, which is at the end here, are both developed for use with organic molecules or carbon-containing molecules. The chemical force field is also similar to UFF in some ways and is generally not as popular. But since we're dealing with an organic molecule, the MMFF and the GAF force fields should probably be used as they are going to be more accurate for this sort of a structure. So I'm going to go ahead and select just the first one, the MMFF94. Nothing's changed yet, but if I now do another energy minimization, we'll see that we get a new energy. There was a slight change in the geometry if you're watching closely. And that energy that we now get is not something that we can compare with the other energy. These force field energies depend on how the force fields are parameterized and are not particularly meaningful unless you're comparing between other molecules with exactly the same atoms. So you can use them for relative energies, but they don't give you any sort of absolute energy. So now I've done my reparameterization. I can go ahead and again select my hydrogen-carbon-hydrogen bond, and you'll notice that nothing shows. So this seems to be a small bug within IQmol. If you translate the molecule to center, which again shouldn't really do anything to the molecule itself, but it moves it so that it's centered at 0, 0, 0. So now the angle shows up, and we can see that the angle is 115.5 degrees, so somewhat less than 120 as we would predict. I can also look at the oxygen-carbon-hydrogen bond, which, as predicted, is now above 120 degrees. It's about 122 degrees. So we can see that just switching the force field did give us somewhat of a better starting point for our geometry. So in the future, we will look at using quantum chemistry calculations so that you don't have to worry about what sort of classical force field you use. But if you want to just look directly at bond lengths and angles, you do want to be somewhat careful about what method you're using and make sure that it's applicable to the molecule that you're looking at.